Well, welcome everyone. Welcome to Understanding EGT Systems, Passenger Vehicles and Light Commercial Vehicles. I'm glad everybody could make it, and hopefully our sound and audio work good throughout this session. You know how the internet can be sometimes. Hopefully we can glide through this with no issues. On behalf of the Diesel Roundtable, Bosch and myself, Karl Schneider, I do want to thank everybody for attending. So before we begin, I just want to tell you a little bit about myself. I've been with Bosch for 9 to 10 years now or so, doing a lot of virtual training, obviously, with the COVID issue. Did leader-led training prior to that for Bosch, and back even in the 90s when I got my start at state colleges and with the Massachusetts emissions program. So personally been married for 30 years or so, 5 children, 14 grandchildren, one great-grandchild. I enjoy, building cars and trucks and so on, just like probably most everybody else online here. So, but anyways, at least you got somebody live that's been in the industry, that's been there and done it for the most part, and enjoy doing what I do. So it's great to be here. So I want to teach you a little bit about this Train Essential platform. This may be close to what you have or somewhat simulate what toolbar you have, but I just want to teach you a little bit of how to run this. So first thing is going to be the course information on your left-hand side, that I that's there. The next thing down is a question tab, so you can ask questions throughout the class. If you'd like to type them in, feel free to do that. Then I'm going to be asking you questions a couple times to gauge the audience and see who I have in my audience and the level that you're at, so I know where to teach to, and also to see if you're paying attention actually in some of the questions I'm going to ask you throughout the program. So we'll get some good feedback on uh, uh, questions on how this EGT system actually works and functions. Again, the chat, some of you already use this. You can chat, I believe, with a group and instructors only, but that's will be determined by the platform. You can see what's there. Um, Handouts are available at times. If there are any handouts, I'm not sure if I put any in this or not, but they would be in this section here. Microphone access, if you can keep it muted throughout the course unless you have a question to ask, that'd be great. There's a note tab where you can take notes throughout the class. And when you want to, anytime during the class, you can do this several times or just at the end, it will be send the email to your email box that you signed up for this class for. And last but not least, when you exit, provide feedback. It lets us have some knowledge of what you guys are looking for out there. If we make it better, faster, stronger, let us know. We're glad to accommodate you for upcoming classes as well. And again, I'm glad to be here and present this to everybody, and I appreciate your time out of your busy days to attend this as well. So one of the first questions I'm going to ask you and teach you how to use these questions is this section here. So just to let you know, I'm going to post all the questions up like this. You cannot select anything from here, but we'll go through the question. We won't go through the answers, but we'll go through the questions, and I will post a poll question up as soon as we go through that. So don't try to select any of this A, B, or C here. It's going to be pretty painful on you trying to select that. But this one is, I want to gauge who I have out there. So how long have you been working as a technician in the field? So now what I'm going to do is I'm going to post this up here, and then you can take a vote on it. There you go. And this is the voting section, and all the questions will be similar to this. Okay, give another second or two here. All right, looks like we got a pretty good mix. You can show everybody the results just so you can see. We have some people that aren't technicians, and we have some people that have been at least 10 years in the field, 11 years in the field, and even longer. Great to have everybody aboard. I appreciate that. Excellent deal. All right, let's continue on here. Okay, so the next question we have here, how do you feel about your general knowledge about exhaust gas aftertreatment systems? And again, I'll post that up here. I'll give it a few more seconds here. Seem to be a little slow voting in, that's fine. Don't be bashful now. If you don't know anything about it, just makes my job a little bit easier in understanding at what level to teach to make sure I address even the small things sometimes. All right. So it seems like everybody that's voted in so far, we still have some that haven't, but it seems like everybody has at least some knowledge of how they work, which is good. We got no newbies at all that don't even know what an exhaust gas treatment after treatment system is. Good to know. Excellent. All right. Okay, so our course agenda for this course is we're going to go over exhaust gas composition of diesel engines. And really, this is pretty much the most important part of it, honestly. I know we're going to talk about the after treatment system, but the reason why this is most important is the after treatment system suffers due to engine performance problems. And a lot of things go unseen and repeat failures happen in the field. And we're going to talk about that, why it's so important to have a good running engine and verify that prior to the repair of a fault of an after treatment system. We're going to talk about the Bosch Denoxtronic layout, that whole after treatment system, this chemical plant on the back of a diesel engine, which I'm sure most of you are aware of. It increased the price of every diesel vehicle out there by somewhere over 10 to 15, $20,000 in some cases, in order to lower the emissions. And the crazy part is, it's only a small segment of emissions, which we'll talk about. I'm going to talk about the sensors or the inputs. We'll talk about testing depth fluid quality and so on, and then we'll do a course summary just to review everything. And that's where the questions kind of start beginning to come in on the summary and trying to revamp your memory bank on things we talked about as well. And then the objective is here is describe the EGT system in operation on passenger vehicles and light commercial vehicle trucks. So we'll include, the big three, the Duramax, the Power Stroke, and the Cummins, and so on, light duty stuff, and the passenger car vehicles. And some stuff's included Sprinter as well within this mix. So first thing I want to talk to you about is the exhaust gas composition and a diesel engine itself. So let's just take what's being exhaled from that diesel engine. Of course, we're taking in air, which is 79% nitrogen, 21% oxygen generally. So what's going out that tailpipe is going to be the majority is that N2 is nitrogen. So we can see that big chunk, and it's an inert gas. It really doesn't harm anything. It's in the air anyways. We breathe it in, breathe it out. Doesn't have any effect on humans or whatever, but it's there for displacement purposes. It's necessary. We didn't want pure oxygen in there, but the next one is the oxygen content. We're going to have some leftover oxygen that's going to be expelled from the cylinders after combustion. And that's going to be what we're going to be labeled as free oxygen. So what I mean by free oxygen, it's just an oxygen molecules out there by itself. It's not attached to anything like the next one down, which is CO2. We have two oxygen molecules that are attached to a carbon atom. They're tightly bound, so it's not free oxygen, and that's going to change how we utilize the content of oxygen in our exhaust after treatment, believe it or not, whether it's free or not, whether we can use it or not. So we got to separate it in order to get it free, in order to do things in that after treatment system, and we'll talk about that as we go through. And then, of course, you have H2O. We have another oxygen molecule in there, and hydrogen as well. So these are components that are being released out the tailpipe that aren't really harmful to us. There's some, discussion with the CO2 raising greenhouse plant, gases and heating up the planet and so on. But that's a whole different topic. But really, the majority of the point I want to get across here to take away from this slide is this really the 0.09%. And that's this other graph, this little sliver that we see here. And this is what we're putting this expensive after treatment system on to lower this small amount of pollutants. So the first one we'll talk about is there's question marks there of the percentage is SO2, sulfur dioxide. And that comes from the sulfur in the fuel. We have lowered it tremendously. Sulfur is a poison to these after treatment system components, so we need to get the majority of it out of there. But there is still some sulfur content that needs to be sort of burned off. We can keep it under control. We're all right. But if the sulfur content starts to climb, then it will poison the components in the after treatment system. So we do want to keep that under control. I don't even know if you could ever find diesel fuel with sulfur in it at any higher parts per million than we had years ago. But if it did, it'd totally ruin the exhaust after treatment system or most of the components in there. The next one is CO, or partially burned fuel, which is a very small amount. It's a 0.04%. CO, the carbon monoxide, one carbon atom, one oxygen atom. Of course, we know how dangerous that is. Very low amounts will kill us if we breathe that in. It's very dangerous to us. So it's partially burned fuel. The 0.034% is NOx, and it's nitrogen and oxygen. The X means of any proportion of oxygen. And it gets very interesting. In this proportion of oxygen, we have to do some funny things with this through that after treatment system in order to get these NOx levels down. And this really came into play. This went up higher when we started going to electronic diesels. So we took out the extra fuel that created particulate, and when we did that, we lowered the particulate amount, but we increased the combustion temperature. And when combustion temperatures go up above 1800 degrees, and you know, with a diesel, that's pretty easy to do normally. So the NOx levels mixing with the nitrogen of the N2 creates this effect, and it creates this NOx effect, which is really bad. It's carcinogen to humans, and we got to try to clean that up before we get out the tailpipe. The next one down is a really small amount of hydrocarbons that's being produced out of there. Diesels are a very efficient engine compared to gasoline, and hydrocarbons is the raw fuel, hydrogen atom, carbon atom. So that's basically fuel that is just didn't get burned at all. And the PM is particulate matter, very small amount of particulate matter being produced. Before electronics in the mid 90s, the particulate matter was grossly bad with that being produced from these vehicles due to the fact that diesel engines run better with more fuel. Obviously, I mean, the more fuel you give it, that thing's a powerhouse, and that was the whole key thing. And most people that had diesels, if they could turn those pumps up and crank that fuel into those cylinders, just gave that vehicle more power to the max. But we had to kind of limit that with electronic diesels, and not that you can't do that today, but we try to shy away from that because we're trying not to overload that after treatment system and produce that black smoke out the tailpipe. And then there's 1% of other 0.001% of other gases that are just added together that don't make up a whole lot. But so in a nutshell, you can see here that we have this very small amount of pollutants that has to be cleaned up by this after treatment system. Unfortunately, it's at a high cost for diesel engines today. And it's kind of a delicate system. So we need to make sure that we keep the engine running, clean and at a 100% efficiency, because we'll damage that. Now, in the past, years before electronic diesel, before this after treatment system, diesel would pull in front of the shop and we could just look at it idling outside or even run down the road and we could just get an idea of what's going on. So this first one, the black smoke, is that partially burned fuel or CO that's pumping out the exhaust. And, we still see this today with people that put performance kits on. And if that after treatment system gets contaminated badly, you can still see it again. But it's a very rare thing that we see this anymore. And also the white smoke, cold engines, typically older diesels, you always saw a little bit of white smoke on a cold engine, especially on cooler days, of that raw fuel just being sent out that and warms up. It usually goes away. But if there's a cylinder just totally misfiring, not firing at all, you can still get that white smoke of unburned fuel. And then the blue smoke obviously would be the oil. And that's a whole different topic. Tony, put together this great program on the oils that are supposed to be put into a diesel engine. It's very critical today. But the whole takeaway from this is, well, we don't see this anymore if that after treatment system is doing its job. But the problem is if this happens for any length of time or in an abundance, it's going to kill that after treatment system. It's going to come into the shop, somebody's going to fix it and think it's all right without checking the engine performance. And then it's going to be back, who knows, a month later, 2 months later, 3 months later for the same exact problem. And then they're going to blame the part and send that back defective. And you know what's going to happen again? Another 2 or 3 months, going to be back again with those same issues, unfortunately. So these are one of the things that we got to be aware of, that we need to verify that the engine is operating properly at 100% efficiency, and we don't have any misfires, anything's not going wrong in the diesel engine and causing these problems. So just a little bit of a tidbit, in our common rail class, we go into how fuel injectors wear and what happens to them. But just so everybody knows that a wearing CRIN or a CRE fuel injector, when they start to wear, they start to add fuel to the engine, extra fuel. So what does that do to the driver, the operator of that vehicle? Well, it makes them feel real good because they're getting tons of power out of that thing. They're going, this thing's never ran so good. It's the best it's ever ran. Well, unfortunately, what's going to suffer? You got it. That after treatment system is going to take a toll, and that's where things are going to get bad for the owner of that vehicle because it gets very costly as well. So, and it gets bad for the repair shop because if it gets missed, that will come back in again. And of course, you're the one that's going to look bad when it comes back in for the same exact problem. You got to tell that customer that, guess what? Well, don't know what's wrong, but anyways, you know what I'm talking about. So let's just talk about this Bosch Denox layout. So this is as a whole. So we got a bunch of components in this system. And to break this down, it gets very confusing with all these components when you first look at this thing. We got catalysts, we got DOCs or diesel oxidating cats, similar to a catalyst in a gasoline engine. We got SCR, selective catalyst reduction. So those two are basically catalysts that should last the life of the vehicle as long as they're maintained properly, the engine's maintained, not contaminated with anything. The next thing is a filter or diesel particulate filter. DPF is what we call it. That's a filter. It's like an air filter, oil filter. And guess what? It's got to be serviced or changed or replaced at some point in time. Control devices, ECU, DCU, so electronic control unit or engine control unit, some may call it, and the dosing control unit. Those two we'll talk about as we go through. The DEF system is going to consist of just a few parts we'll talk about: the tank heater pod, the supply module, dosing module, and heater supply lines. In order to thaw that DEF fluid out, unfortunately it freezes, so we're facing some other problems when we added this system on. And we'll talk about the sensors as well in the system. So I figured one of the best ways to describe this system and understand it a little better is to go through each component separately. So the first thing I'm going to talk about is what's called a diesel pre-oxidating cat. In the beginning, they actually had a pre-oxidating cat in a separate can, just let it do it on its own, and then they now combined it all together. So it's really in one can that you're going to see it, or one component. But there is a pre-oxidating cat. The idea of this pre-oxidating cat, it's very robust as compared to the rest of the catalytic converter or diesel oxidating cat, because it's going to take that shot of fuel that's going to be running down there, raw fuel, in order to do this. In order to do that, it's going to begin the heating process. So it's going to be very hot, now over 550, 600 degrees. It's going to take that shot of fuel, and it's going to start igniting inside there, building up heat inside there. So the very beginning of the pre-cat, which all of them have, like I said, in the same component now, begins that process. And also begins the process of the HC and CO oxidization process as well. So we want to oxidate that similar to a gasoline combustion engine, pretty much does the same process of oxidation, breaking these components down into separate components. And we're going to rejoin them again later on or after the DOC into components that are going to be, well, hopefully harmless if everything's working properly. So to continue on with that, the diesel oxidating cat is in the same can now, typically behind that. And it's a larger piece of substrate that does the same similar things, but it also reduces PM. And oddly enough, it actually separates the NOx too. It separates the NOx into components that can be broken down into the SCR as well. So this DOC is doing a lot of work. Most the beginning vehicles were equipped with DOCs to start with. It was one of the first devices that we added to them to try to help with HC and CO. Those are the early model diesels that typically are worth a bundle right now because everybody wants to get them, stick at this after treatment system thing. So these early model diesels are really one of the nicer ones to get. Most of them are all common rail that had these on there as well. So, and also again, it still builds up that heat for that after treatment system in order for the hydrocarbon introduction. If we don't get the heat built up, something happens to this converter, we're not going to get above that 500, 600 degree mark in order to even put fuel in here. We're not going to be able to do anything with this converter. It's basically going to be a useless piece inside there, not being able to get up to temperature. So temperatures being controlled by the turbo, and the engine itself is going to have to build temperatures up in order to get it hot enough for this unit to work and start injecting fuel. Most of our light duty passenger stuff is introduced through the injection system. Medium, heavy duty, a lot of them have a separate injector that injects fuel down into the exhaust stream. We'll get a little bit deeper into that as well. Things that can happen to this, well, a big rock can take these out. You know, guys four-wheeling, smash that case and crack that unit inside there. It's mounted in inside of some insulation or a wire mat to help dampen the vibrations because it is kind of fragile. It breaks apart pretty easy. It's like this, most of them are made of this substrate. Some are wound as well. But nevertheless, either what they are, we got to be careful with them, make sure we don't damage them. Other things can happen to them. They can get poisoned from components. The fuel itself, if it overloads it with fuel, can cause problems with it. They can overheat and crack the substrate as well, or even cause meltdowns inside there, similar to a gasoline meltdown as well. That does the same process. Oils can contaminate it, the wrong types of oil that are put into these diesel engines, because there's always some blow by the rings. There's nothing you can do about it. It's what it is. And as a matter of fact, it's even worse with the light duty passenger vehicles because the service intervals are a little bit more frequent in those due to the fact that they know this after treatment, when it's being induced into the engine, that it does do wash down of the oil. So we're getting fuel in the oil as it is. That adds for more blow by and more fuel to go by there with the oil as well. So contamination of that happens. We can cause face plugging. That can actually put a coating on the front of the pre-cat and cause flow problems, causing that cat, pretty well useless. Antifreeze, definitely a poison to it. Once that gets in and coats it at a certain amount, its life's pretty much over. It can contaminate it as well. Other components, if you make it long enough to put DEF fluid in there, that can also not help these out as very well either, because that's before the DEF injector. The SCR can take it, but the DOC probably not a good thing for that as well. And some people put actually gasoline and diesel fuel, and yeah, nobody's seen that happen before, right? Yeah, sure. But it's amazing. We get calls from brand new vehicles that have DEF and gasoline contamination continually. I don't know how people do this, but it happens. I guess it's good job security for everybody in the diesel world, but it does happen. So those are things to watch out for damage to the DOCs or the pre-DOCs as well. So the next thing we'll deal with here is the diesel particulate filter. So basically what we're doing is the particulate matter is what we're going to call soot. So it's going to filter that soot. And we have this filter that's going to grab that soot and only allow the exhaust gases to flow through here when everything's working properly. We're going to do subtle regens when the conditions are right. A lot often the regens is actually going to take and heat this up, and it's going to burn that soot and turn it into ash is the idea of this whole thing. So similar to your charcoal grill, if anybody's ever burned charcoal in any period of time, you burn enough charcoal, you're going to have a big ash pit at the bottom after you cook with your charcoal after a certain time, 3 or 4 times. And sooner or later, guess what? The ash isn't going to go away. It's got to be cleaned out. So the same thing with this. Most light duty commercial vehicles and passenger cars, they need to be replaced. There's not too many that are cleanable until you get to medium heavy duty trucks. So keep that in mind. It's a replaceable unit in most cases once the ash load gets to a certain amount of those conditions. So what we have is we have chambers up inside here. Let me just try to expand this a little bit for you here so you can see this a little bit better. So we have our PM going into here, and it collects on the sidewalls of these chambers that are open on the inlet side. The outlet side of here are closed off every other chamber, and we can see where the green arrows come out. And hopefully everything that goes through this DPF, the filter, it filters out all the particles and only allows just exhaust flow through there. So we're cleaning that particular area. When everything's working good, temperature's right. We do those subtle regens when the temperature's high enough. Major regens will be done on a vehicle that's driven over 30 miles an hour for over 30 minutes. So we get the temperature hot enough under normal running conditions. It can do these fairly good regens on them. At some point in time, if the vehicle conditions aren't met enough times where it doesn't reach that 30 miles an hour for 30 minutes and the temperature's not hot enough to do these low city vehicles and so on, may have to even come into a repair shop to have a stationary regen done, and a scan tool will be put on it 30, 45 minutes later after a high RPM and vast amount of noise from cooling fans and everything running high RPMs and exhaust flowing out that tailpipe will burn that particulate matter off and turn it into soot. But again, the soot load does matter. We got to keep an eye on that as well. So what can damage these? A lot of the stuff I mentioned earlier, coolants, heavy fuels, gasoline can damage the DPF. They can crack. One good way to see if a DPF is cracked it's really simple, is if the inside of the tailpipe is dirtier than the outside, and then typically you got a cracked DPF. Wipe your finger inside there. If there's any black soot on there, chances are that DPF is cracked and particulate matter is flowing out of that thing. But they do plug up as well. And like I said, passenger cars and light duty trucks is a replaceable item in most cases. All right, so let's add on the next thing in line. And I want to say the next thing in line, these two can be reversed. The DPF and the SCR, doesn't really matter what order they go in, they can be reversed. To give you an example, Ford 6.7 truck chassis, F250 and 350, if they're a cabin chassis, they will have them in this order. The pickup truck style, I believe, will have them reversed. I might have that inversed, but nevertheless, they can switch them around. So even on the same type of vehicle, same years, they reverse them. And the reason why is a lot of times is real estate underneath the cabin chassis. The frame rails are probably closer together, so they can't quite fit the way they want to between the frame rails and with all the stuff underneath there, so they reverse them. But same thing, works the same. We're just going to go in this order for conversation. So the SCR, again, is catalyst. Precious metals in there, like the rest of them we talked about. It's going to utilize some other components called DEF fluid that's going to reduce the NOx in the system. Again, high temperatures are required for this to work. And what we're going to do is, let me expand this a little bit here so you can see this a little bit better. So through the process of the catalyst here, we're going to take the NOx in, and actually we want to actually split that up. We can take that NOx, want to split it up in the DOC, believe it or not. We're going to bring that down there. So this isn't really a true reflection of what it is, but to make it a little bit more simplistic, we're actually going to take that NOx and we're going to take the NH3 or ammonia in that. And along with the H2O, which isn't shown here too, we're going to actually use that because there's a mixture of NH3 or urea in the DEF fluid along with water as well. But to give you an idea of what we're going to do, we're going to go through this SCR process. It's toxic going in, it's harmless going out. So we're going to split up these molecules and we're going to rearrange them. And we hopefully, once we rearrange the NOx, the NH3, we're going to come out with N2 and H2O in a perfect world. We do the best job we can, but you got to realize that on and off the throttle acceleration times, we have to map that with the dosing module in order to dose the right amount of fluid. And I'm going to get into that a little deeper, but it's a challenge to try to hit that target exactly. So when you put your foot in it right away, you're probably going to see a NOx climb up really, really high. There's nothing you can do about it until the DEF fluid gets through the system and starts converting in the SCR. Like I said, I'll talk a little bit more about that after. But through hydrolysis, we do a reduction process in this SCR in order to lower these products down inside here. All right. So what happens to the SCR when it goes bad? Again, same thing. It can get poisoned. It can get cracked. Very similar to all these devices. The same thing can affect all these in order to damage them. So if you have an engine problem not running properly, all three of these can take an effect. One might take the hit more if it's caught in time, and two of them might be able to be saved or whatnot. But the sooner the operator gets it in and it's diagnosed correctly, the better off we're going to be. So again, another thing we have to realize is that when we put DEF fluid into the system, we have ammonia in there. So in the beginning process of this, they started with ammonia sensors. They didn't work out too well. And even if we had an ammonia sensor, we knew what the ammonia level was. But what good did it do? We knew it was high. What are we going to do? We'll still produce ammonia out the tailpipe. It's got a pungent odor. It's really takes your breath away if you smell it. So we need to get rid of that if there's any extra ammonia left over. And again, on and off the throttle, let's just take an example of how we get extra ammonia in the system. So let's say we put our foot in the throttle and NOx goes up high, and the system, the DCU finally says, okay, we got to start dosing because my NOx levels went high according to the NOx sensor. So we start dosing in there. Well, now what happens is we're equaled out under the same load conditions, let's say, and this truck is going up a hill with a boat behind it, cranking up this hill under real heavy load. Well, when you get to the top of the hill, you lift your foot off the throttle. So now what happens? The inverse happens with this thing now. So now what we're going to do is we're going to be dosing heavy. We're going to have a lot of that DEF fluid with the ammonia going through there. That's not going to be utilized. Guess what's going out the tailpipe? Before the ammonia slip catalyst was put in there, we had an excess amount of ammonia. So now, and these are all within the same can as well now. The beginning ones were a separate can. Now they're joined together with the SCR. And the SCR with that ammonia slip at the back of there, the very end of that converter is now taking care of that ammonia slip, is what we call that, to eliminate the ammonia, burn it off so we don't have that excess ammonia going out the tailpipe. All working good. We have harmless gases coming out the tailpipe, I hope. So the next thing I want to talk about is the DEF supply tank. So we have to supply DEF fluid. Most of these systems contain enough DEF fluid in them to go one service interval. So let's just say the service interval for the vehicle is 5,000 miles. Under normal conditions, the amount of fluid that's in the tank, and there's a equation for this to go, for every 50 gallons of diesel fuel burned, they'll use 1 ounce of DEF fluid. So just an idea of how they do this math simulation to say 5,000 miles, the amount of fuel per miles we're going to get, this should be the amount of DEF fluid we carry in our vehicle. Trucks aren't a problem. We can put a fairly good sized tank. I mean, some of the early models like the Duramax, they had that tank that hung down real low. If you had a 4-wheel drive, you were in jeopardy of hitting that tank with that tank hanging down there. So they've done a better job of sticking the tank up inside there now. But that's not the real challenge. Trucks are a little bit easier, but passenger cars are tough. So you got to realize that, you know, we may not need as much in a lighter vehicle because it's going to get better fuel mileage. So that equation is going to be less DEF fluid. But however, there's less room in them too. There's no place to put them but inside the vehicle somewhere. So some of them are in the trunk where the spare tire used to be, and eliminates the spare tire, of course. You know, you get a nice little can of sealer and a vacuum pump. It's not a pressure pump now, so you can pump it up. Hopefully, if the hole's not gaping out of there, you can seal it up. But you know what I mean. However, some of them didn't want to take the trunk room away, so what they did was they put tanks, maybe multiple ones, in the rear behind the passenger seat and tried to fit them in here or squeeze them in here. Well, some of the tanks that they put in there, some manufacturers put a second tank above the first tank, and the first tank's the lower tank's a fill tank. So in order to get fluid to the second tank that's above the fill port, you had to pressurize it. So it took a special tool in order to do that. Some aftermarket tools made this like accordion style bottle to push it in there and pressurize it in there. Probably works for a bit, but nevertheless, filling these up can be a hassle, but we have to put tanks somewhere in them. And the real estate that's in them left over in passenger cars especially is very, very tough. So that's what the supply tank's job to do, is to do that job, is to keep that supply there. DEF supply module, we have a supply module in the tank. It's going to deliver DEF to the dosing module itself. It's going to reverse flow somehow to clear the lines out. We got quality sensors in most of the new stuff today. I'm going to say if equipped. Some of the older ones didn't have the quality sensor. It based it on the performance of the SCR. So it said if the SCR wasn't performing right, well, it's an SCR performance problem, and everybody went to the SCR. But now with the quality sensor, it'll give us an idea, because if the quality is not right, the SCR can't work properly. So now what we have, that quality sensor to check the quality as well. I still advise you to check it manually, and we'll talk about that in a minute. Temperature sensor, we need to know the temperature in order to thaw the fluid out, which we'll talk about freezing temperatures in a second. Electric heaters throughout the system, depends on what type of system and how many heaters we're going to have in it. And I'll get into that because there's a couple different Bosch systems that we have out there. And also a level sensor, that's gone through a few different generation changes too. We've made them a lot better than we have before. And we'll talk about those different generation changes and the benefits that we have of them as well. So here we got another review question. Let's see who's been paying attention. So when the ash load in the passenger vehicle's diesel particulate filter reaches a specific level, it needs to be, and there's 4 possible choices here. So I'm going to post that question up. And if you can vote on that, that'd be great. And as your answer knows, I see a few people have joined us here. I want to welcome everybody. Maybe a little bit late, but thanks for attending. All right, I'm going to give it a few more seconds. I still have quite a few people that haven't voted in. And it might be somebody that joined after we discussed this topic. All right, so guess what we got to do here? I'm going to post this up so everybody can see this. All right, so we'll post this results up here because I want everybody to see where everybody voted. And to everybody's defense, you may not have been here when I discussed this, and you might have got confused how this process works. But one of the things I want to mention is, let's talk about the question first. The question asked about ash load, okay? So when we talked about this, soot goes through the system. It's burned through regeneration into ash. So this asks when the ash load in a particular filter reaches a specific level, it needs to be, and the correct answer is B, it needs to be replaced. Most passenger cars, it's not serviceable, it's a replaceable unit. Stationary regeneration using a scan tool would have been true if the soot level was high in a passenger vehicle and it couldn't meet specific conditions to be burned off. So that's when that condition in the A would have been correct in that place. Removed and cleaned. I guess we got some heavy duty guys in here that are used to removing and clean them and didn't listen to what I said about being replaced. That's fine. But the light duty stuff typically is a replaceable unit. Check with the OE. I have not seen too many that actually offer a resolve for that to be cleaned. But most of them require remove and cleaned. And I know a few of you guys are out there going, yeah, well, I think that's fine. And I understand that that can be done. But if we go from the OE side, that's the procedure that the OE recommends on the light duty side passenger car stuff. And D, we'll discuss that as well, because some people have answered that too. Driven at 30 miles an hour or higher for 30 minutes. That's the conditions for a major regen on the vehicle on its own. So it's going to do subtle ones when conditions are right, but when we get the vehicle at a high you know, a 30-mile-an-hour where the RPMs are high enough with over 30 minutes, so we build up enough heat in there. We're actually going to do a active regen on it and regen it as we're driving it. Some do stationary regens, just sitting there. The vehicles are capable of doing their own stationary regen with the vehicle itself, where a switch is on the dash and it's able to do that. Medium heavy duty passenger cars don't do that. They'd have to be brought into a repair shop where a scan tool would be put on there and it would be taken through a cleaning process, but that's not to clean the ash, it's to clean the soot. Once the ash load gets high enough, you're pretty much all done with that. All right. Great job, everybody. I appreciate you. Appreciate you going through those questions. That's great. All right. Now let's talk about, we got a couple different systems I'm going to talk about here. So the first of the lion's share of them right now that most of you guys are going to encounter, because these are the ones that are that you're going to see mostly out there, because these were the first generation ones, is the Denoxtronic 3.1 system. It takes a DEF fluid, flows it from the tank to the dosing module. When the pump is energized, when it's energized, when the 4 and 2 valve is de-energized. So we're going to just energize the pump. Nothing else is going to be energized, and we're going to push fluid from the supply module to the dosing module. When the engine shut down, the 4x2 valve and the pump are both energized at the same exact time. And what that's going to do is take the DEF fluid and it's going to flow it from the dosing module back to the tank. Basically, we're going to purge the lines of fluid, evacuate them. This design does have serviceable parts. It has a heating pod and a supply module that can replace separately. One thing I do want to mention, though, when you pull this unit out from the top, if I can expand this a little bit here, probably be easy to see this top one. This unit comes out of here. It's bolted down, this top section. When this is taken off, there's a tube that goes down into the top of the reservoir. There's a little tiny O-ring in there. And that O-ring, especially when it's dark in your bays or in an area where you can't see very well, or you just pull the tank down enough to pull that off of there, that O-ring can often go misplaced. It can just fall and disappear into the atmosphere somehow or another, never to be seen again. And if it doesn't get put back in, it's going to create a great leak and you're going to have worse problems than when you began. So again, be cautious of that O-ring when you're servicing the 3.1 system. So this has what's called a 4x2 switching valve. It only has one pump in it, and the pump always spins in the same exact direction. 4x2 switching valve is in charge of reversing the flow of the fluid from the supply pump to the dosing module, and then from the dosing module, it's going to purge all the air out of it back to the tank. So we're going to take a look at how this works and how this dosing, this 4x2 valve works from the dosing module back. So here we have a video. We're going to turn the ignition on in this vehicle. We're going to run the pump in a forward direction. We're going to fill the system up, the 4x2 valve. It's going to run through. Once it gets to the pump from suction side, it's going to pressurize it. We do have some backflow. I'm going to fill that chamber up and fill it up to the dosing module. We're going to energize that 4x2 valve. We shut the key off. Pump's going to start to run and reverse that flow. It's going to draw the fluid from the dosing module back through. It's going to be pressurized on the opposite side, and it's going to go back to the tank side. When it's all done, we're going to de-energize it. So when does it do that? Every single time the vehicle is shut down. This is the reason why. Let's just say you get up in the morning, start your vehicle up. You got a 3-minute drive to the convenience store to get your coffee. You shut it off at the coffee shop. Guess what's going to happen? That's going to happen just what you just saw. It's going to evacuate those lines every single time. Reason for it is, it doesn't know how long it's going to be shut off for. It could be 5 minutes. It could be 3 days. It could be a month. So we got to evacuate those lines every single time we turn it off. And this is how the 3.1 system works. Like I said, these are the most common that you're going to see out there at this time. Now let's talk about the 5.X system. And I say the 5.X because there's different generations of these. Although they're very similar to one another, they just have different configurations and how they're mounted in the vehicle. So there are a lot more benefits from this 5.X system that we have. It's mounted from the bottom of the supply tank. So as you saw, the 3.1, the pump's at the top. We have to draw the fluid from the bottom of the tank, which allows more conditions that can happen from leaks in the hoses or connections inside there and possibly draw air. So we've eliminated that when we mount this at the bottom of the tank. So it's sitting basically right in fluid. It's got a quicker response time to the DEF dosing module because the fluid's always right there armed with it. It's got a quicker thawing time for the DEF fluid. So when we thaw it, the heat has got to turn on. So we can thaw it right around the inlet port now, where before we do it around the inlet port, but everything's got to be thawed. The lines inside, the pump up at the top, So everything's got to work all together. So the time-wise takes longer with the 3.1 system. And there is time that's allowable by the EPA on any diesel when the certain temperatures are there. So it's at, let's say, minus 20 degrees. They only give you so much time for that fluid to be thawed. I don't know what the time is for every temperature because it's different from everyone. But just an example, I'm just throwing it out there. I'm guessing at this. So if it's minus 20 degrees, they give you 28 minutes to thaw that fluid and start dosing. So there is time limits that they give you before this vehicle has to start dosing that fluid. So this pump that we're looking at on the right-hand side is inverted. It actually goes up into the bottom of the tank if you see it. So the layout of this system is a little bit different. Of the 3.1 is now what we have is two pumps. So we have a supply pump and a purge pump now. We do not use that 4x2 valve anymore. So this is all done with different pump directions. So we have increased the filterization, and the reason we had to do that was now this is sitting in the bottom of the tank, and all the debris or whatever gets in there for contamination is going to fall to the bottom. So we want to make sure we filter it to give it its best life, although there's a fine line between filter and a plug in the system. So we want to keep the debris out, but if there's a lot of debris in there, that filter is going to act as a plug. And this unit is not serviceable other than the unit itself. The whole unit has to be replaced. So you can't just replace a pump or the heating pod. It's a complete unit. But nevertheless, it can be serviced as a unit. Most manufacturers do offer a system to do that. So let's take a look at this one in action, how it works. So this one we're going to turn the key on, and we're going to start our supply pump up, and it's going to pull fluid from inside the tank right to it. It's going to be very quick because it's right there. It's going to go over to the dosing valve, and then we bring fluid up to that purge pump. When the key's shut off, the purge pump starts up, and we reverse that action. We're going to drain, pull the fluid out of that dosing valve all the way up and push it back into the tank to evacuate those lines. So the idea is to get all that fluid out of those lines so when we shut the vehicle down, we don't have a freezing condition. So now let's take a little look side by side, a comparison of other features that make this 5.1 a little bit better. We were able to increase the pressure in here. So when we increase the pressure, we increase the atomization inside the exhaust tract where it sprays into the decomposition valve. So it gives us the ability to atomize it better, and especially for heavy duty uses vehicles, we can dose much better and get it decomposed better through the SCR. It says airless systems. I don't know why we put that up there, but some of the medium heavy duty were air injected systems that they had in the Denox 2.1 system, which isn't used anymore. We used that at the beginning of the Denox project. They were used on limited vehicles, but it was a stepping stone to where we are at Denox 2.2 medium heavy duty. The Denox 3.1 is only air cooled, the dosing module on the exhaust. The Denox 5Xs, we were able to have it air cooled or water cooled, and the reason why is the location where it's mounted. So if it's mounted closer to the engine where the temperatures are higher, the water cooled one's a better option to keep it cooler, where the air cooled just can't quite supply that as well. All right. So now let's talk about level sensors. So the beginning level sensors we had, we'll call a discrete sensor. They were a passive sensor. It required measuring current supplied by the ECU. Urea solution closed an electrical circuit between the electrodes for each level. Each of these levels are customer specific. So we got 80, 30, and 10% here. It all changes from manufacturer to manufacturer what they want for levels, but it could only tell you where it is at certain levels. It couldn't give you a real accurate reading. So the accurate reading says plus or minus 2 millimeters. Well, it's not taking into consideration oscillations of vehicle moving, so it's only with a vehicle sitting there. So really, it worked for what we had at the time. But the problem with these is that they were probes sitting in there, and they were in corrosive atmosphere. So these probes got corroded. Corrosion actually worked their way up into the wiring of the system, and once it got into the wiring, it corroded the wiring and caused resistance issues, and then caused input issues to the ECU. Well, the problem with that is when it starts causing that issue, it can put the vehicle into different modes that the operator's not going to like too well. So they put systems in here that they're not going to let these systems run low. If it runs low, what's going to happen is they're going to put the vehicle into different conditions to where the vehicle may just idle or not even start in some cases if it's empty. So if the tank's full and it thinks it's empty because the level sense is defective, guess what's going to happen? We're going to have drivability conditions that are going to affect it. So now let's take a look at one of these level senses. I'm going to run through this a couple times. So the senses you see in the middle there, when it's white, it's open. When it's blue, it's closed. We see no lights on at the top. We see a light come on halfway. About a third of the tank in different areas, it'll start flashing the def level light on the dash for the driver. Then when it drops down and the next sensor comes on, we're going to see that it's going to reduce the power and the speed of the vehicle. It's going to flash a light and push the stop engine light on in some vehicles. And this is just an example. And then when it goes down even lower, guess what's going to happen? It's only going to maybe idle only or no restart, depends on what the manufacturer wants. So give you an idea of how that all works. I'll just let it run through a second time so you can just digest that because it went pretty fast. But that's how these discrete sensors worked at that time. Pretty much most manufacturers have gotten away from these now. Most of them have veered off to the next sensor I'm going to talk about in a moment. I'll let this finish its ride through here. Let you see how it works. All right. And then we're down to a no start. That's going to be real interesting on the side of the highway if you don't keep your DEF fluid full. Make sure you keep some with you at all times if you can. So the ultrasonic level sensor, let's talk about, measures the DEF fluid in a liquid state. This is the newest style sensor. It gives a measurement based on time of flight principles. The sensor emits ultrasonic pulses, which the surface of the median reflects the sensor, detects again. So now this is mounted in the bottom in that 5-point X system, and we're casting that signal up to the top of the tank, and that reflection that it gives back again. And the great part about this is it can be moving fluid. It can still get a measurement anytime. So it can measure even moving fluid now. So we can get a pretty accurate level. And this is the generations where they started putting gauges on the DEF tanks. So now we can actually put like a fuel gauge. We can put a DEF level gauge in there and we can accurately measure it anytime we want. So it gives a much accurate measurement now so we can tell exactly what that fluid level is. Hopefully to prevent these operators of these vehicles from driving them and running these things low and causing drivability issues. So basically, it measures off time of flight is what we're doing with these. It's a piezoelectric sensors with the reflection back of the fluid. So mostly the newer vehicles, and the first one I saw that started utilizing these, I believe it was that 1500 Dodge, that V6 engine that we had with a gauge on the dash with it. But now most everything that we see today is probably using this ultrasonic. Of course, it was probably more expensive than the discrete, but the price, of course, using them more often now, everybody's using them, prices come down. This 5.1 system seems to be the lion's share of everything that we use in vehicles now. Not that we don't offer the 3.1 to manufacturers, but if they want it, they can still purchase it. But we still offer both of them to them. So DEF temperature is also another important input. This is a sensor out of a 5-point X system. It measures the temperature of the fluid, so it knows when to turn the heaters on and off in the system. Located in the DEF supply tank and allows an input for quick thawing of the DEF fluid with predetermined limits after startup and freezing temperatures. So manufacturers set their own predetermined temperatures where you see the temperature and they'll turn the heaters on to make sure that we have good thawed fluid in there. Don't forget most of it's 67.5% water. So the water has an effect of freezing, but with the urea in there, it actually lowers the freezing temperature of it. So we have a lower temperature that it freezes at, but still it does freeze. Don't forget it will turn to like a slush first and before it starts to get frozen solid. So another thing to keep an eye on as well. So let's see here, do another review question here for you. I'm sure you're excited about that. The most accurate way of measuring diesel exhaust fluid or DEF tank level is, and there's 4 possible choices here. Let me post them up there for you. There you go. All right. Great job, everybody. Let me post this up there. I do want to discuss this. Thanks, everybody, for not choosing a measuring stick. Obviously, we know that's not the correct answer. The discrete sensor really isn't the most accurate way because we have only 3 sensors in there that measure that probe, and the rest of it's based off of mileage of the vehicle in between those sensors and says, well, I burned so much from 100% to 80%. I should be at that 80% level soon or in between the 80 and the 30% or whatever it is. A The floating arm sensor, we don't use them being a corrosive factor, area that the floating arm style, like a gasoline or a diesel fuel floating arm type sensor, would never take the corrosion factor that we're in there. And it has a hard time even in the diesel fuel and the gasoline as well, with the components to make it out of it. I mean, some of them are gold plated uh, sensors as well, but it still can't take that corrosion. So definitely would take it out. So whoever answered C would have been correct. Great job, everybody. I appreciate your input. Excellent. All right. So now let's continue on, talk about the dosing module itself. That's going to dose the DEF fluid into the exhaust tract. It's a demand-based. Depends on the engine control system and what we're going to inject into the system. This basically is similar to a gasoline fuel injector if you hold it in your hand. There are different spray angles and volumes for all vehicles out there. So be sure that you match it up correctly, because if it doses the incorrect amount, obviously we're going to have performance problems with the SCR. And the reason I'm saying that is it's happened. These sensors may fit into another dosing unit if you take it apart. Unfortunately, some of them are very similar. They don't look any different, but the part numbers are different. So cause performance problems, and it really drive a technician that didn't do it in circles, just trying to figure it out what's wrong with it if it's the wrong part number, because you have to disassemble it, match the part numbers up, and so on. It's the last thing you would think of that anybody would do, is put the wrong part number in there, but it happens. So just something to keep in the back of your head when you're working on these. But sprays requirement on DEF for the after treatment system for the reduction of NOx in that system. These do plug up. There are problems that happen with them. If the DEF fluid isn't atomized properly and spray just before the decomposition tube, what happens is it can go in large amounts and not atomize, or get stuck in the bottom of the exhaust and start corroding. We've had some systems that actually plug the exhaust completely and cause a no start of an engine, lost a lot of power, and then finally a no start where the exhaust couldn't get out of the system. And really the fix for it was just disassemble it, run water over it, dissolve it, and put it back together, and you're back good again. But you got to replace the dosing module, because if it's not spraying properly. And I'll show you how to test that as well to get an idea of if it's atomizing properly. It's not the easiest thing to do when it's working right. You can't really tell because it's atomizing, but when it's not working right, believe me, you'll be able to tell that the injector is partially plugged. And there's some serviceabilities with these as well. So the two different kinds we talked about earlier was a air-cooled and a liquid-cooled. So two different ones I'm showing you here. The air-cooled obviously is the lion's share of them. The liquid-cooled is more popular when we put the SCR in front of the DPF, because it's closer and it's got to be in front of the SCR. So it's closer to the engine and right behind the DOC, where the temperatures are a lot higher than than they are behind that. So we would probably use a water cooled in that case. And there are some close coupled systems that are newly coming out. There's a Mercedes, several years old now, that Bosch has designed the after treatment system for, that's right on the engine. So all the whole after treatment system is right close to the engine, or what they call close coupled. We still do use DEF to dose in there, but we don't use hydrocarbon dosing anymore in those systems. So if you heard that, and this is one of the things I hear, well, I heard they're not dosing anymore. Well, it depends on what they're dosing. So we call two things dosing: hydrocarbons, that's fuel, and we call the DEF fluid dosing as well. So no systems that I know of yet have eliminated DEF fluid. We're still using that in every application that I know of. But the close coupled systems, and the Mercedes is the first one that we have. I don't know if it's available in the US, but it's a European right now. But it probably will soon be over here once it meets EPA standards. I'm sure we're not going to be dosing hydrocarbons in there. So yay, we got a win now. We actually aren't using diesel fuel for the after treatment system, so we can use it to power the wheels. So maybe we'll get a mileage or two back out of those vehicles once we perfect this thing. So able to be inducted into high temperatures. The spray volumes and patterns all different from manufacturer to manufacturer. And then occasionally these do need to be serviced. So during service interval, it's not a bad idea to pull these off and check them. So it's due to corrosive nature, they build up corrosion on the right around the inlet of the outlet, of these injectors. So servicing is required at certain times. Let me expand this for you, because it's kind of hard to see right here, but you can see there's three little holes there, possibly. I hope you're not on your phone, you may not be able to see it, but if you're on a PC, you can, or computer. Around the outside, you can see the corrosion. So what happens is that corrosion will build up and cause the spray pattern to be interfered with that and cause it not to spray properly into the exhaust track. And that's where we get the plugged up exhaust systems as well during those times. And this is just a picture of somebody testing this. I'll show you this live in a second here of the test pattern. It's going to go pretty quick, but use a graduated cylinder. Most scan tools have a test for this, by the way, in order to check that. I'll give you an example of one in a second. So when you're testing, you can observe the spray pattern as well as the quality of the fluid as well. We need to make sure the quality is good during that test. So we're going to check the quantity being sprayed in. We're going to check the spray pattern. We're going to check the quality of it during this test. So bidirectional controls will allow that testing to be done for the module. It can vary either by weight or volume. So different manufacturers will give you the spec on it, but most of them are by volume, but there are some that do it by weight. So if you did it by weight, you need to scale. You're going to measure a pre-wet tube or a graduated cylinder, and then you're going to do your test and run it through there, and then you're going to take the weighted amount of the graduated cylinder away from the amount that you tested, and that'll be the way of it. But it's fairly simple math. Verify the spray pattern or restricted injector and the total volume of the system. So here we got highlighted the test of the AdBlue measuring amount. And this goes through pretty quick, but I just want to give you an idea of what can be done with it. So here we are. We select the AdBlue test in here. It gives you the cautions. Don't do this, don't do that, whatever. Select the continue button to continue. This test is to be performed twice to make sure you get an accurate reading, and combine the two. Wear suitable clothing and safety glasses. Please do that. Remove the components from the AdBlue, the whole injector from it. Leave it plugged in with the lines hooked up, and you're going to put it into a measured container is what that's telling you. This is a diagram of it being put in there. We're going to go through an elapsed time test because it takes some time to go in there. We can check the pressure as well. And then we got the amount. So this amount is looking for the amount in grams. So this is a weight amount on this Sprinter here that we got. And guess what? We put 50 in there, and guess what it says? The value is not good. So you'd have to know what the good value is, I guess, to figure out what you need in there. But that would give the whole thing away if you just fudged it, or you're going to have to figure out why you don't have the correct amount in there, whether it's more or less. Don't know that right now for this conversation, but it gives you an idea of what you need in there. And like I said, most scan tools give you the opportunity to do this. It's a fairly quick and easy test, and it gives you a chance to service that as well. And any performance test, that's probably one of the first things you should probably do when you get there. So here we got the decomposition valve, allows the DEF fluid to convert from ammonia through hydrolysis and break that down into the components that it needs to, that NH3 and the H2O. Evenly distributed throughout the whole SCR. So we're going to spread it out evenly so it goes through that honeycomb directly through there. So let me expand this. This is just a couple different decomposition tubes that we have. I believe this one on the left is a Ford F-Series decomposition, and the one on the right is a Mercedes style. They're different designs, but each manufacturer has their own little recipe or medicine that they put in there to say, I want it to do this or do that. And that's how they come up with what they put in there for that decomposition tube. But it's ultimately doing basically the same effect. It's spreading it out to spread that out throughout that SCR in order to do that reduction process through there. All right, so now we have these seem simple. There's supply lines, but there's probably more to it than you know. So these supply lines send the DEF fluid to the tank. It heats it up during certain temperature times. This is showing you a heater up here that is kind of small. You see this one depicted here, but honestly, it's wrapped from the beginning of the module, the supply module, all the way down to the dosing module. So it's a wire wrapped all the way down there, and basically it's just cause an electrical short basically in that wire, just enough to heat that wire up and thaw that line out. I know it's empty when we shut the key off, but there could be residual fluid in there, and if it plugs up that line, then we're going to have issues with dosing. So we got to thaw that out, and that's the reason to do that. If that goes bad, depends on the manufacturer. It can cause drivability issues, but a lot of them will just give you a message on a message center on the instrument cluster and a code set as well to say that there is a heater fault in the system. And they're pretty sophisticated. Most vehicles today will break it down to an open, short, and give you test procedures for following through, trying to diagnose those. All right, so here we have the DCU, which is a dosing control unit, which is going to take all the inputs that it has, and it's going to deliver the outputs and what needs to be sent to the SCR or the dosing module. So basically, it's kind of like the brains of the outfit. It takes all its inputs and then decides what outputs it's going to be needed. But most vehicles typically have a separate, unique dosing module. All right. Well, guess what time it is again? Everybody's going to be excited. It's a review question time again. So here we go. See if you're paying attention. On engine shutdown with the ambient temperatures of 83 degrees Fahrenheit, the diesel exhaust fluid is, and there's four possible choices here for you. Let me bring that up. All righty. So I'm going to post the results, and I see a few people are paying attention. If you would have, you know, answered C, you've been correct. Evacuated to prevent freezing, which would be the correct answer. So let's talk about this for a little bit here to make sure we understand what's going on. So on engine shutdown, um, heated with the tank heater. So basically, I haven't heard of anything that heats up the fluid other than the heaters to um, heat the fluid up for any reason. But the tank heaters are just not to heat the fluid up, we're just thawing the fluid is what we're doing. So purge to remove the air in the lines. We do purge the air in the lines, um, but not on, on engine shutdown. Let's just see here. So back up. Yeah, good. Okay, so evacuate to prevent freezing. That's what we're going to do is evacuate those lines. And D is pump through the DEF cooler. I don't know of anybody that runs a DEF cooler in these systems, but great job, everybody. Again, let's see if we can pay a little more attention to know what's going on. And again, 83 degrees. Guess what? We're still going to evacuate those lines. So we're not going to use the heaters for anything. We're going to evacuate those lines to prevent freezing. Even though it's 83 degrees, doesn't matter. We don't know how long it's going to be shut off. And it's some vehicles. I mean, it can be 80 degrees in the daytime, and it can be freezing temperatures overnight. So depends on where you live, I guess. Might make a difference on knowing how to answer that question as well. All right, so now let's talk about inputs or the sensors in the system. So undoubtedly, one of the most important sensors that are in the system are going to be the exhaust gas temperature sensors. And honestly, the whole system is diagnosed itself, most of it with these exhaust temperature sensors. It can basically get a baseline of what's going on with each separate device in the system. So it's a critical input for operation. Checks the operation of each device throughout the exhaust track. They're positive coefficient sensors, and that means a positive coefficient sensor. First off, what it means, I'll tell you that in a second, but basically, they're there because of the long reach of temperatures that it has to go through. So it has to know ambient temperatures wherever the vehicle's sitting overnight in any temperature. So minus 20 degrees, I guess, let's say, or even colder. It has to know that temperature. And then it has to go up to, 1500 degrees or even higher in a lot of cases for these sensors. Most of your sensors of negative coefficient size are for like engine coolant temperature sensors, which only have a small track as compared to these. So it goes from minus 40 to 300 degrees, let's say. So that's fairly small as compared to these sensors. So a positive coefficient sensor as uh, the resistance increases as the temperature increases. A negative coefficient sensor, as the temperature increases, the resistance decreases. So a little bit different operation due to the fact that the temperature span is much higher, and that's why we use a positive coefficient sensors for the most part. Thermal management for the exhaust after treatment system, it's very important input for it. One of those goes bad, we basically have a faulty system. It doesn't know what to do and how to do it. So it's going to probably pause everything. The hydrocarbon dosing, possibly even a def dosing if it can't get enough data. It really messes with it. It could be put in limp mode in a lot of cases as well. So drivability concerns as well. DPF protects against overheating. We got to protect that. It does use OBD2 monitoring through the DOC, DPF, and SCR catalyst. The system may have up to 5 sensors in it from what we've seen so far. Not to say that there may be some more in the near future, but basically most of the stuff that's built within the past 2 to 3 years has 4 sensors at a minimum, and probably 5. Some of the early models ones may have 3 or even 2 sometimes in some cases. go back even further. They may have even started with 1, I guess, in some cases. But the temperatures downstream for the key management for the thermal system for regeneration as well as SCR target is about 1160 for the average vehicle. So somewhere between 11 and 1200, I guess we can say. The temperature upstream of the DOC helps to determine HC convertibility in the DOC itself. So these are a lot of problems getting them out of the system. Even after a short amount of time, they're in a corrosive atmosphere. And I don't mean just the DEF fluid's corrosive, but the exhaust fluid itself is corrosive as well. The exhaust is just the exhaust itself and the high temperatures cause these things. They're very small and they break off quite often. So it's a challenge to mess around with these, especially once it hits a 50,000 mile mark, they can be a challenge to get in and out of there. So watching these things are very important to understand how this system all functions and works. And if you understand how the temperature sensors correlate, if you follow them, you can get a good idea of how that system is actually operating as a whole. The exhaust gas temperatures is used for performance testing. The exhaust needs to reach a specific temperature for DPF regeneration, and that is probably around that 550 degree mark. So somewhere between 500 and 600 for the average vehicle. Before hydrocarbons can be dosed in the system, it has to reset its temperature. So that's the job of the turbo and the engine control system to bring that temperature up there. If that can't do that, if there's an engine performance problem, it can't reach that temperature, it's not going to dose hydrocarbons because it's no use of doing that. If we put it in the DOC, it's going to contaminate the DOC and the rest of the system after that. So there are temperatures that need to be reached. The regeneration process includes hydrocarbon dosing as well. So now let's take a look at this. This graph is, I know it's a busy graph that you see here, but we're gonna play this graph out for you. I'll try to pause it if I can through it. So this is our first sensor number 1 in the system. We're gonna bring in sensor number 2 throughout here. I don't know if I can pause this thing or not. Let me just try. Okay, so let's just study this. I'll pause this thing here. So we can see around that 500 degree mark, we can see that temperature increase very, very quickly from the first sensor to the second sensor. So that second sensor is after the DOC, and we can see that temperature increase at that point when it was able to dose the hydrocarbons in there. So they mimicked one another up to that point. Then once hydrocarbons got dosed in there during this performance test, it's a force test usually during startup conditions of most diesel vehicles. It'll go through its own test to see if this is working properly. So the second sensors say, now, guess what? Now I can build up a lot of heat in the system. Everything really looks good. So now let's continue on. We'll add the third sensor, which will be behind the DPF. This particular vehicle that we're testing here. So we're going to see that sensor come into play. It's going to be a gray line that's going to come in there. It's pretty much going to follow that other line fairly close to the system as it goes through there. And there are different times of performance tests that'll drop down. Hydrocarbons will stop dosing, then boost it back up again. That's where you see that blip in there. It's just a performance test that's going through. And then the fourth sensor here, this is the intake of the SCR. It's going to go, it's a little bit cooler going through that process, DEF fluid being dosed in there. So it's going to be a little bit change in temperature, but follow that fairly closely. And then the next one, we're going to see probably just a little bit more of a drop for this other one because it's behind the SCR. Don't forget we got water in there that we're putting in there, so it's going to be a little bit cooler too. But the takeaway from this is to understand that it's a good idea to follow these systems throughout to make sure that these temperatures are maintaining the correct temperature throughout the system. And honestly, if you can coin in on the temperatures and understand how they work on a good working vehicle, you should be able to pick out the faulty parts that are in the after-treatment system on a faulty system and understand how that works. So most systems today on the new ones are using a differential pressure sensor. They used them before too. All manufacturers didn't use these all the time, but for the most part, pretty much everybody's using these in coordination with other things. So differential pressure sensor, basically you get two PIDs, turn the key on, engine off. They should equal one another because obviously the pressure is equal on both sides without the engine running. Start the engine up and you should see a differential in pressure. And by the way, not much. It doesn't take much to trigger this to say that the DPF is restricted. There should be hardly any restriction in that at any given time, even prior to an act of regeneration. And typically when this gets to a high point is when it's got to be brought in for a forced regeneration. So it's monitoring this at all times, and it doesn't take much, believe me, for this thing to indicate that there might be a plug in the system. So this sensor here measures the drop between pressures, measure the determined amount of ash content in the system as well. So you compare the signals to the input and the output is really the best way to follow these things around to see if they're working properly. All right, so particulate sensor is behind the DPF. Most of our newer stuff has this. I'm saying probably 17 and on. The preliminary ones of these didn't last long because it's got to go through a process similar to the DPF and burn it off in a regeneration kind of on its own. So it's going to sit behind a DPF and it's going to determine if it's efficient or not. So it's going to build up soot on that sensor and it's going to accumulate. It's cause electricity signal to go across here for the input to the DCU. So it's going to detect the non-filtered soot, and the electrolysis between the polarities of the sensor will determine how much soot is being passed through a particulate matter. Periodic regeneration again is being done. It's going to heat that sensor up. It's going to burn it off and bring it back to its new life state. So this sensor again, it's a smart sensor. It's got its own module in there. Together because the signals are so low that if it were distributed over all the way up to the ECU, which could be, I don't know, it could be up on the engine compartment, and this is mounted in the back of it, it would lose a signal because it's in very, very low voltage. So it's got its own smart signal there. It has that analog signal. It breaks that down with a AD converter, and it brings it to a digital signal and puts it over the bus, the CAN bus. It'll deliver that to the modules that's necessary to receive that data. OBD2 control for the DPF function as well. So again, very critical sensor. These go bad. These aren't as bad to get out as the EGTs, but they still do fail occasionally, and they can get in that corrosive environment. They can still be a bad to get out of there at times. So not NOx sensors we have in here. So most of these have, most newer vehicles, probably 19 and up, all have dual sensors in them now. Not all of them, but most of them go into that area. Before that, there was an optional #1 sensor. They could do a lot of it with the rear, but most of it to meet EPA standards to really rectify this thing and know exactly what's going on and get more codes as well. They put 2 sensors in them now, so it can see what the NOx levels are prior to going into the SCR, and it can see what it does after. So the downstream one is basically the efficiency of the SCR. But with 2 of them, we get a much better and more accurate indicator of what may be wrong. Is it the DEF fluid? Is it the temperatures or whatever going through there? We can get that NOx levels. We know exactly what they are going in and what they're coming out as. So again, the NOx sensors are smart sensors too. They got their own module in them. The signal's so low they can't distribute that all the way up. They put it over the CAN data bus and deliver it to the modules that are needed. Standard position after the SCR, additional ones that can be put in for an optional one be prior to that. Precise measurement of the NOx concentration. And just a little a tidbit here, just so you know, we call them NOx sensors, but honestly, they're an oxygen sensor. They are doing the same process that an oxygen sensor does or a wideband sensor does. And it's really not measuring the NOx, it's measuring the oxygen content in millivolts. And the amount of oxygen content that's stripped away from the nitrogen, now it can determine the exact oxygen content that was, the nitrogen content that was in the exhaust stream by the amount of nitrogen. This is why the DOC in the beginning, I told you at the beginning of class when we went over the DOC, that it does just more than HC and CO and PM. It does a splitting of the NOx, and it splits that up into components because the SCR can't do that. So it has to be done prior to getting to that. And that's a whole nother class, unfortunately, because it's pretty in-depth when we get into that area. But anyways, increasing applications in medium heavy-duty vehicles just for the amount of emission control that we need on vehicles. And actually off-road, I don't mention it here, but off-road vehicles are going this route too. So again, smart sensor, it's all one piece. You can't change it separately. These can be a bad to get out too. These are very similar to the EGTs. They can lock in there and have a trouble getting them out. Usually, even just to get them out and check them, it's a destruction thing. So unfortunately, that's just nature of the beast to where it is. So using SCR performance testing for the NOx sensors also can be done. On startup, the engine runs through test and pre-verification. So it looks at cold startup, it begins the test. It can look at light off. Then it burns off the moisture on a sensor that's been sitting. We need to burn that off there. So it gives it sort of this extra heat flash to burn that off there along with the exhaust. The rear one takes a little bit longer. You can see here, it takes a little bit longer time because we want to get the exhaust temperature to slowly heat it up. I say slowly within, 20 seconds at the most probably, but a little bit slower before we turn the heater on so we don't crack it. So we got that. And then we have clean and purging. So the purging is going to purge the air out of the lines and fill them up with DEF fluid. And the cleaning is cleaning of the end of the DEF module. We want to get the corrosion that sat on there overnight or how long it sat and just get that cleaned off enough to make sure it's going to purge properly. You see those oscillations in there, and that's the DEF and DOSI module opening and closing injecting DEF into the exhaust stream. So the next thing it's going to do is it's going to really crank up the NOx with the engine control system without any activation of DEF fluid. It wants to see how high the NOx levels can go, and then it wants to see if it can lower them naturally. So the engine's not going to change its strategy. It's going to keep producing NOx, and it's going to see now when we start dosing if we can actually lower the NOx reduction, out the back of that SCR with dosing it. And it's a pretty good test for it. These are where codes will set right out of the gate if within the first 3 to 5 minutes of running a vehicle, if there's a performance problem. Most vehicles do this test behind the scenes that you can't see during the beginning test of a vehicle. And that's an OBD2 compliance thing to make sure that we meet certain standards and the system's capable of working before we take off with that. So the next thing down the line is the hydrocarbon dosing, and we're going to use the ECU to control that. It's going to be done with late ignition timing. Maybe only used on one bank due to EGR cooler. We don't want to run raw fuel through the EGR cooler. That would definitely cause a problem with that. Plug that up too fast. So some manufacturers just choose to use one bank for dosing. Same fuel injectors. The fuel injectors are identical to the other bank. There's no difference in them. It just has a different strategy to do an after injection of the system. And it may even have a couple after injections of just a minuscule amount of fuel into there. But when you're doing 4 injectors, it's enough to get into the DOC after that 550 degrees, light that off, and to increase that temperature of that exhaust stream. As we saw in that demonstration, that temperature climbed very, very quickly as soon as we needed to. Most commonly in passenger cars and light duty trucks, we do it with the engine control system. Medium heavy duty, done with a separate injector right in front of the DOC. The problem with this is cause oil dilution. I mentioned that at the beginning. So service intervals need to be monitored very, very closely, especially if we're going doing a lot of regenerations. And this is another problem that happens as well. So the vehicle has other issues, and it's doing a lot of regenerations, more than normal, because of other problems. Now what's going to suffer is we're doing more dosing into the engine, and we're doing more oil dilution as well. So it's this catapulting effect of this whole thing going down and happening, causing more problems to happen as one item goes bad. So again, if something fails in this whole after treatment system, you must take time and look at the engine control system to see if there's any problems with that at all. Really, it's a key factor in that. And again, diesel engines, injectors, when they start to wear, even if it's a piezo injector or a solenoid, it's going to start injecting more fuel into most cases. So keep that in mind. So more fuel is going to cause problems. Well, guess what time it is again? It's another review question for everybody. So this one here is the optional upstream NOx sensor is used for, and there's 4 possible choices for you. Give you that in a sec. There you go. Okay, I'll give it another couple seconds here. All right. Not everybody voted in now, but I do want to talk about this for a bit. I'm going to show you the results here. So the majority of people answered B. Unfortunately, that's not the correct answer. So I'm going to go back through this program. So, and you can vote on this. Now that you know the answer, it's probably going to be a little bit easier for you. But let me just take you back just a tad here. I'm going to talk about this. I want to mention. So here we have our upstream and our downstream. So here our upstream is used for NOx input and dosing volume. And really, that's what that sensor is used for. The downstream is used for the SCR efficiency as well. So C would have been your correct answer on that. So good job, everybody. I appreciate you voting in, but it was for the dosing quantity that front one sensor for would have been the correct answer. So now let's talk a little bit about the DEF fluid in the exhaust. So we have this DEF fluid. I don't know why they put the name diesel exhaust on here or the name diesel, because some of these fill tubes are right next to the diesel fuel. It's a constant battle. Brand new truck just recently on our help desk line came through where brand new Cummins application, somebody put DEF fluid in it, destroyed the whole system. It's going to be thousands of dollars to replace this system. But anyways, DEF fluid, 67.5% water and 32.5% urea. It's synthetic urea. No cats were harmed during the making of DEF fluid. I honestly believe that. Anyways, this isn't a science or anything. All DEF manufacturers have to meet this quality here. So it's deionized water and synthetic urea. So if it doesn't meet this standard, then we're going to definitely have problems. And that's where the test tool comes in. We see this OTC 5025 refractometer that can be used for testing. Even though some of them have quality sensors, could there be a problem with the quality sensor? It's not a bad idea when you take your sample to test the fluid anyways to see if everything's working properly. It's a colorless clear fluid, similar to what density of water. It does change the freezing temperatures. As I mentioned earlier, water freezes at 32 degrees where we have this at 12 degrees. So, water turns to slush at first. It doesn't freeze solid right away, and then it goes to its solid form. And the same thing happens with this DEF fluid. It will freeze completely solid during cold temperatures for a certain length of time. Storage temperatures, they recommend between 23 and 77 degrees Fahrenheit. That's a farce because how are you ever going to keep it in a vehicle? Let's just say, certain industries are affected by this, like motorhomes right now. I live in the Northeast, and motorhomes right now are being parked for the winter, and they're going to sit there with the amount of DEF fluid that's in that tank. It's going to be frozen solid all winter long. And in my mind, it's definitely going to affect the quality of that fluid. So DEF quality codes could happen. One manufacturer that we dealt with in the passenger car side, they told their technicians if it came in with a DEF quality code, drain the fluid, replace the fluid, clear the code, send the car down the road. If it comes back, obviously, then there's other problems. But most of the time, it can be a quality code that they had. And that was probably preliminary quality sensors, but now it can give a little bit more information to the system. But nevertheless, this stuff can't be stored in direct sunlight as well. I know a lot of truck stops put it right in their front window and clear containers like you see here. Sunlight can get in there, and it does affect the quality of the DEF fluid. Don't forget water evaporates. So if it's left open, you got water evaporation, more urea, which isn't good as well. I mean, it needs to be pretty much this exact formula that we see here. And it does say 18-month shelf life too, so it doesn't last forever. So don't buy too large quantities where you're not going to use it. Okay, so also it's highly corrosive. We see the fill port over here that's corrosive around that. That's on a Sprinter vehicle that just cups it in there and just builds up after a while. It doesn't take much to dissolve it though. Just fill that with water and rinse it out. Probably just dissolve it out of there. But nevertheless, it is a corrosive factor. And similar to DEF fluid in the diesel fuel, the opposite does happen where people put diesel fuel in a DEF fluid. I don't think it's quite as costly when you do that, but they can do that. So there are test strips for this that aren't cheap, but you can stick these test strips in. They'll white when you begin. You stick them in there, and the different color of blues or the intenseness of the blue will determine how much and the type of fluid that's in the fluid itself. So these are available as well to everybody out there to test for the contamination of the DEF. And believe it or not, it does happen. It's crazy that how could gasoline get in there, but honest to God, it happens. It's just crazy. All right, so we got another review question here for you, and this one is, what is the freezing point for DEF fluid? Let me bring that up for you. By the way, this will probably make you happy. I think this is the last question. All right, so everybody hasn't voted in, but I'm going to continue on and show you results of this. And if you would have answered A, you would have been correct. A is correct answer, 12 degrees Fahrenheit. 32 degrees is water. Minus 12 is pretty darn cold, but it froze long before that. Minus 40 is even colder. So anyway, if you answer that, great job, everybody. I appreciate your input on that. All right. Okay, so now we're just going to do a quick summary. We're nearing our 1.5 hours we got here. So I want to go over what we talked about. And if you got any questions, you can start typing them in there, or we can turn your microphones on if you don't already have them on, and we can ask questions verbally. So first thing we went over is exhaust gas composition of diesel engine. Make sure that thing's running at its premium before you can begin any diagnosing this after treatment system. We went over and built our system from the ground up, and we built it just as the manufacturers did from the beginning of an after treatment system to today's after treatment system. The input sensors that are added on there, the importance of those to make sure they're working properly is extremely important. Talked about the DEF fluid, the quality and the testing of it. And we described the EDT system operation on passenger vehicles and light trucks. Okay, now we're in here for questions. And as everybody's looking at their questions, this is how you can ask questions either way. It doesn't matter either way. You can turn your microphone on. I think Anna Marie gave everybody access to it, so feel free to turn your microphone on and ask for the crowd. But either way, these are the icons that you would have it. But as your questions are building up and getting there, on behalf of this diesel network, Bosch, and my name, Karl Schneider, the instructor for the day. I want to thank everybody for attending. Hopefully it was informational for you. And at the end of this, there is going to be a survey that pops up when you exit this class. If you could take a moment and give us some feedback on how you enjoyed this class, or anything that we can change and make it a little bit different for you as well. We'd appreciate that. All right. Let's just see if we got any questions in here. Okay. I got somebody's microphone on. Do you want to ask a question or somebody typing? Okay, I got a chat one here. Hey, Phil, thanks for being on here. Hopefully see you on here. I appreciate having you there. I'll hopefully see you soon, Phil. Thanks again. Okay, so we do have a question for Phil. I don't know if he's still on here, but how are newer vehicles, say 2016 or 17 and up, dosing with reliability with the sensors and modules? So Phil, that's a great question. The reliability of these things is very, very tough to keep. It's in a bad environment. Every day we're working for longevity of these sensors to make sure they last as long as possible. They have to make it through warranty. This is the clincher of it. And the warranties of even diesel engines are approaching 150,000 miles, passenger cars and light trucks. So in order to make them through warranty, to make it through that area, they have to be pretty robust. So one of the hardest ones was the particulate matter sensor. I remember being at an OBD2 conference in Indianapolis probably 5 years ago, and EPA said all vehicles are going to have this within the next year. And the engineer from Ford, I believe it was, got up there and says, we don't have the technology to do that right now. They can't make it through warranty. And pretty much EPA said, too bad, find one that works. You got to make it to work through warranty period. So, and we have, for the most part, most of these sensors are making it through there, but it is a challenge, Phil, but I appreciate that question. And also another question here. I know Chrysler was warrantying a lot of these items, even out of warranty, and that is true. They've extended some of the warranties on a lot of these items. So you guys that are in the aftermarket, it's really a benefit to your customer to see if some of these sensors are warranted through the OE, and some of them may have even put warranties even extending beyond the warranty limits of the vehicle. So it's always a good idea to check to see if there is a warranty available as well. Excellent questions. I heard somebody's mic on. Does somebody want to ask a question? Somebody's voice fit mine. Give me a break to get a drink of water. Anybody?
I guess they're a little shy, aren't they, Carl?
Well, that happens occasionally, I do have another question here from Steve. Since a DPF is technically a serviceable part, is there any type of service interval for it? Basically, an estimate time of ash load and replacement. So, Steve, let me just make a correction. So, on the light duty side, these are technically well, I guess you could say this. I guess serviceable is kind of like a mixed word. So serviceable means replaceable. And if that's what you're getting at, so I'm going to say serviceable. I'm thinking you think are replaceable in the light duty passenger cars because that's the only option that the manufacturer typically gives you. Is there an estimate amount of time? And there isn't. It depends on the operation of the vehicle, honestly. Is that vehicle operated at high speeds and has time to do that regeneration and burn off? And the fuel economy of the vehicle and the way it's running, the type of oil that's in there. Oh gosh, another one I thought about is biofuel. I didn't even think of that too as well. Oh, that's another thing that adds to this whole after treatment system thing. Biofuel is another issue that we have, not only with the engine of higher interval service rates, but it also takes an effect on the after treatment system. So hopefully this answers your question. I don't have an answer for you. It depends on a lot of factors that come involved with this thing on the replacement time. All you got to do is wait for the code to set. You can check the ash load with a scan tool. If you feel diesel vehicles are coming in, you can see what the ash load is and see if it's near the level of replacement on that particular vehicle. I don't know where those are posted, on what level it is where it needs to be replaced, but it'd be an interesting topic to figure that out. Yep, thanks, Steve. Yep, that's what I thought. Excellent. Good deal. Who else we got on here?
I've got another question, if you don't mind.
Oh, not at all, Phil. Hey, good to hear from you, by the way.
Yeah, sorry, little family event took place. I had to run out.
Not to worry.
So I've also seen these crazy things about DPF cleaners, chemicals you're putting down the intake, and you see this foam coming out of the back of the car. I can't imagine it does anything that they claim. It's just
okay. So
to me, once it's clogged, it's clogged. You're done. Maybe you can bake it and blow it out, but
well, that's a good topic because we've always talked about that snake oil. I mean, you go from air conditioning systems to engine oils and so on, Phil. We've all dealt with that. So from Bosch's standpoint, and I'm just going to give you our standpoint, that in our diesel fuel systems, we do not endorse any additive at all. If you put good quality diesel fuel in the system, that system should run for the longevity of that vehicle. Okay. Don't forget, some additives that are in diesel fuel to begin with are basically detergents, and that takes away from lubrication. So if there's any detergent particles or molecules in that additive that you're adding in there, definitely takes a toll on the fuel system. The DEF system can't take anything different than that 67.5, 32.5%. Anything other than that, we're going to get performance problems. It may not damage the pump or the injectors, but it's definitely going to take a toll on the performance and accuracy of that reducing NOx in the system. So that's also an effect. The other stuff that they put in the intake to clean that system out, I honestly think that if the manufacturer endorsed something, I would say if they do it, then maybe I would stick with that and maybe utilize what they endorse. But if they haven't done thousands of dollars worth of research to make sure it doesn't harm the vehicle, that it does more good than harm, I would say there's probably a better chance that it's adequate. But I am always skeptical in my own thing. And it's an expensive system. If it does harm to it, I mean, who's going to pay for that? You're talking, damaging that whole system can be in excess of $10,000 if everything needs to be replaced in there. So again, I mean, if people have tried stuff and it worked for them in the past, it's not the same Oldsmobile diesel that your grandfather had years ago. It's a whole new world today with diesel engines. So I don't know if that helps anybody or hurts anybody with that conversation, but it is a good conversation to talk about.
Not to mention the effects of those cleaners you can pour in on the sensors, like the NOx sensor he discussed, and the exhaust gas temperature sensors, and even the pressure differential.
Oh, geez, Tony. Yeah, you're right. I didn't even think of that. You're right. Those sensors. Yeah. What about that particulate sensor that we have in there? If that gets on that, is that going to contaminate that similar to antifreeze or gasoline or something as well? Yeah. So it can take an effect on those. Great job, Tony. I appreciate you adding to that.
Okay. Any other questions for my good friend Karl Schneider? Any other questions? Take advantage. You got the Bosch man here.
And if anybody wants to chime in on their experiences too, feel free to.
Jim Wilson still on? Where's Jim Wilson? I saw Jim Wilson in here. Is he still on? Or did he have to go? I think he had to go. But no, Jim Wilson.
He's active. Oh, he says out. He might just be.
He might have to step out.
He didn't check out, but he's just away from right now. So, yeah.
Well, I think you did a great job, Karl.
Well, thank you very much,
Tony. Great job. I appreciate you doing this for the DDR, Diesel Driveability Roundtable here. So I really do appreciate it. So last call for questions.
No, I think we're good.
Okay. Excellent. Well, I appreciate you inviting me to this, Tony, and everybody else. I appreciate your time taking out of your day to spend this last hour and a half with us. And hopefully you got something that will help you along understanding these systems.
And thank you, Mr. Karl. Thank you very much. Again, can't say enough thanks to you guys in Bosch.
Yeah, you're very welcome. Glad to help you guys out anytime.
All righty. With that, let's log off and everybody have a good afternoon.
All right.
Appreciate
Thanks, guys.
you coming. Appreciate everybody coming. Thank you.
Bye now.